13.5 and 27 on 2, those are equivalent. Minus a third and 27 on 2, or 13.5. That's not the same thing. So, Troy, I think it was you who told me you got minus a third. Can you explain to me how you got that?
Well, never mind. Never mind. I was thinking something.
So, you got the answer, right?
Yeah.
That seems very unsure.
Make a mistake.
Okay, cool. Just want to know what your mistake is, right? So this is the answer. You could leave it as 2702 or 27 on 2, or you could put 13.5. Don't forget your units, units squared, square units, unit. Just want to put units squared. Or you could put square units, right? Same thing. Everybody good here?
Yes, yes.
Unit what? Unit squares?
Yeah, unit squared. Or some people put square units. Same thing. Just want to put your units. Okay? That's very important.
All right.
Can I clear this now?
Yeah.
Okay, I want you to try. This is not really the ideal question either. Anyways, try this one for me. Yeah. So just remember, we did all the other questions already. I really just did this as a recap, but I know you could have done that by yourself. Well, the people who were with me, I know you could have done that by yourself. That was just me recapping. So now it's your turn. Do this one for me, and then that's it for area. And as requested, you can take a 5-minute break. But I asked you to show that the finite area of the curve y is equal to sin x in the first quadrant is bounded by the line x is equal to 4 pi on 9 is smaller than the finite region y is equal to cos x in the same quadrant bounded by the same line. Real words, 20 words, I know. Very simple though. Very, very simple. All they want you to do, find the area of the region under this curve bounded by, this line, x is equal to 4 pi on 9. And then do the same for the curve y is equal to cos x. The limit is still 4 pi on 9. And compare the values. Just show that this value, the area, when you get the value of the area, when you find the area under this curve compared to this one, the value is smaller, right? That's all you're doing. Railroads, but very simple. So all we're doing is finding the area under each of the curves and showing that the one for sine is smaller than the one for cos. That's all you do. So the first curve we're talking about is y is equal to sine x. And they said it's bounded by x is equal to 4 pi on 9. And they didn't mention another one. And most times that means that the other line is x equal to 0, right? So just remember that. In the last question, they actually mentioned the two lines that x is equal to 0 and x is equal to 3. When they mention only one, so in this case, they just said x is equal to 4 pi on 9, it implies that the other one is x is equal to 0, right? So all you have to do, use your rule to find the area of the region. So A is equal to the integral of f of x. Remember, f of x is the equation of the curve. So whatever the equation of the curve is, that is the f of x. Dx. Dx just means it's like this, right? Upper limit b, lower limit a. This is definite integration, so you must put your upper and your lower limit. they gave you everything you need. So unlike the other question where you have to go find the equation of the curve and then use this formula, they gave you everything you need. So all you need to do is substitute all this information into your formula, find your area. F of x is the equation of the curve. They told me that the equation of the curve here is sine x. So sine x is my f of x, right? So it's a is equal to the integral f of x, I said, it's sine x. So sine x is the equation of the curve. Dx just means with respect to x. B, my upper limit is always the bigger value. In this case, if I'm comparing 4 pi on 9 with 0, 4 pi on 9 is obviously the bigger number. So that is my B. I put it up here. A, small value, 0. From here, all you need to do, apply your rules of definite integration, find the value of the area. How do I, use definite integration to find the area? That's what we were doing before. First, you integrate this expression right here. So just forgetting the limits for a while. Just focus on integrating this expression. When you integrate the expression, then you substitute the values of the upper and the lower limits, subtract them. Same thing we were doing, right? So the first thing, integrate this. Just forgetting this for a while, focus on integrating this expression. So what would I get? When I integrate sine x, what would I get? What's the integral of sine x? Anybody? Okay. Oh, they remember I said my exam already, huh? I already know this. Minus cos x is the integral of sine x. Then you put your bracket. Upper limit is 4 pi on 9. Lower limit is 0. And all you're doing is substituting the values into this, get your answer. So I am erasing this. So first I'm going to substitute the upper limit. We know that's already, right? None of this is new. The first thing you do is substitute your upper limit into the expression. So in your first bracket, it would be minus cos. Instead of putting x, I'm going to put the upper limit. So that's 4 pi on 9 minus, taking the same expression, or wherever I see x, I'm now going to replace it with my lower limit, which in this case is 0. So that's cos of 0. So remember these, see when you see pi and things, like a trig function, and then you see that the angle is in terms of pi, you know you're dealing with radians, right? So one time, put your calculator in radian mode. If you don't do that, you get it wrong, okay? Because this angle is in radians. I know that because of the pi right here. So if I find minus cos 4 pi on 9, can anybody tell me what's that value? Careful with your brackets when you're putting it into your calculator. What's the value of minus cosine of 4 pi on 9?
Negative 0.17.
Okay. Be careful here, right? I don't know. Maybe for certain years they might take the approximate answer. But just to be safe, try to keep the exact answer. Just to be safe. So it's minus 0.17, yeah. But it's like a whole long decimal, right? So using that whole long decimal, cos of 0 is 1, so this will become minus 1. Let me just I'm putting dot 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 here, right?
Quick question, right? So, but do you really have to insert that entire figure again, or could you use significant figures? Or
I mean, in this calculation, before you subtract,
yes.
like I was saying, I know sometimes they accept it, not just for like any subject that requires a calculation and has decimals in it. I know sometimes they accept it, so you put, the approximate answer here. You have your negative 0.17, and then you continue. But I know other times your answer might be off. Not always, right? But your answer might be off because you approximated too early. So to avoid that, that's what I was telling you, to use the exact value for the decimal. Because if you approximate too early, you might get an answer that's slightly off. And we don't want that to happen, right? So that's why I encourage you to use the exact value. So I just put an ellipse right here. Anyway, to represent that decimal, that whole long decimal, then minus 1, that's really just plus 1. My final answer for this thing is 0.8 positive, right? 0.826. Just 3 significant figures.
So in this case, for like your final answer, leave the 3 significant figures.
Yeah, because that's the final answer. I'm not going to manipulate this anymore. But
so if you put the entire figure, like all 8 decimals, like 0.8263518222233, is that correct?
I mean, for this question
Where generally, do they expect you, when you're putting your final answer, if it's not explicitly stated, it's a 2 or 3 or 1 significant figure, to put the exact value?
No, because at the beginning of the paper, like the exam paper at the very front, most times it states where necessary, like put your answer to 3 significant figures. It's actually stated on the front of the paper of the exam paper. Yeah, that's why it's really important for you to read the instructions, because let's say a moderator did not, any moderator, what do you call these people? Invigilator, they don't read the instructions for you, then you go and put your answer to 4 significant figures and you lose a mark just because you didn't follow the instructions.
I think they stopped do that, and I think invigilators stop read the instructions, and they're supposed to read it, but
Yeah,
I never had anyone really read it to me.
Yeah, that's why it's really important for you to read the instructions, because if they say 3 significant figures and you go and put 4 or 5, well, if there was a mark allocated to that, then you're going to lose the mark because you didn't follow the instructions. Okay, so remember to read the instructions. So this is the area, unit squared, right? This is the area for the curve y is equal to sine x bounded by the line 4 pi on 9, right? So we found the one for the sine. Now we need to find the one for cos. I'm using it. I'm using the whole thing, right? The other equation was y is equal to cos x. Like I said, all we do is finding the area of each curve, comparing them. We need to show that you see that value for the sine we just got, the 0.826. We need to show that the value we get for this one is going to be greater than that 0.826, right? That's all this question is asking me for. So if I want to find the area for this, remember x is still the 4 pi on 9 on 0, right? So using my same formula, p a f of x dx, f of x, which is the equation of the curve, in this case is cos x. So what do? All I need to do is substitute my value. B, which is the larger number, in this case it's still 4 pi on 9, because the said in the question, bounded by the same line, right? So it's still the 4 pi on 9 and 0. But in this case, f of x is cos of x. So that's the equation of my cos. Cos of x dx. Do what you know you're supposed to do. Use the rules of definite integration to find the value of the area. So, you know, the first thing you have to do is integrate this expression cos x to find the integral. Can anybody tell me what's the integral of cos x? What's the integral of cos x?
Don't know if I missed it, but do you think is there like a notes where they tell you what the integral like sine x is? Because I may have missed that completely.
Can you repeat that?
When you ask like what's the integral like minus sine x and you say it's like cos x, is there like some notes on that, or because I may have missed the class when that was sent?
Yes, there's a rule that I showed you before. Well, I showed the class before. The one that says, so let me choose sine. I'm doing the integral of sine, right? The integral of sine is minus 1 on a. Let me write it up. So if I want to find the integral of, the rule was like this, right? Sine, my angle is ax plus b. Then the integral of this is minus 1 on a cos, and the angle remains the same. Ax plus b. A is the coefficient of x. So whatever number comes before x, that's my a, right? So if I had asked you to find the integral of sine x like we did just now, sine x, following my rule, which says minus 1 on a in this case, which is the coefficient of x, is going to be 1, right? So that's the same as saying minus 1 on 1 cos of ax plus b. In this case, my ax plus b is really just x. So what I'm going to put is cos x. And that's why the integral of sine x is equal to minus cos x. I'm just following the rule. You good with that?
Yeah.
If you're not good at it, I will do it again, right? So what's the integral of cos x? I did
Sine
sine x just now. Wait, repeat.
Sine x.
Sine x. Good job. And then you put your bracket, you know, you put the upper limit here, the lower limit down here, substitute the two values. So my first bracket is going to be sine of 4 pi on 9. My next bracket, so this is minus, then I substitute the 0 into here, that's sine of 0. I already know that sine of 0 is 0, so not really worrying about that bracket. Right now, what my main focus is this right here, the sine of 4 pi on 9. Can anybody tell me what's that value? What's the value of sine of 4 pi on 9? Remember to put your calculator in radian mode. What's the value?
0.984807753.
Okay, so just three significant figures, right? 0.985. So what you need to do, make a concluding statement. They ask you to show that the area for the sine graph was smaller than the area for the cos graph. So your statement might be like, remember units, right? Units squared. Your statement might be something like, 0.826 units squared is less than 0.985 units squared, and therefore the area under the curve y is equal to sine x bounded by the line x is equal to 4 pi on 9 is less than the area bounded by the curve y is equal to cos x on the line on the same line. Something like that. Just put a concluded statement to show, yes, I did prove that this area is smaller than this area. Okay? You understand that? Yes? No?
Yes, miss.
Okay. There's nothing too difficult, right? It's really just, it was just kind of long, but not difficult. So as I said, as I promised, 5 minutes. Last thing for integration. Yay. Finding volume. That's another use of definite integration, right? We just finished learning about how to find the area under a curve. Now we learn how to find the volume of something called a solid of revolution. So when a portion of a curve is rotated 360 degrees, also known as pi radians, about the x-axis, a solid will be generated, and this is called a solid of revolution. So I thought it was, I think it's best if you can actually see what that looks like. So hold on, let me just get it. Like I found a video to show you what exactly that looks like, right?
Wait, could you quickly go back to the slide so I can screenshot, please?
Okay, these screenshots. Why are these screenshotting?
I usually screenshot it and then I rewrite the notes properly instead of rushing it to write it down while you're doing it.
Let's see. Let me know when you're done. I can show you the video. It's a very short thing. I just want to
Okay,
see what it
done.
looks like. So this is just to show you what exactly that solid of revolution, what it looks like. Not everybody would pick up on what I'm talking about by just reading what I just read. It would be better if you actually saw it for yourself. So this is a curve that they have here. F of x is equal to the root of x, right? This is what this curve would look like, starting from the origin and going all the way up, right? So hold on, just go back. Okay.
Around the x-axis.
Hold on. Can you hear this?
From 0 to 1.
Can you hear that? Yes? No? Did you hear that?
Yes, yes.
Okay. Okay. Actually, let me just put up the link. Right.
Let's fill in this area between the curve and the x-axis so we can see it. Now imagine grabbing this little piece with your hand and rotating it 360 degrees around the x-axis so that it never leaves the axis. And we see that it traces a three-dimensional shape in doing so.
Right. So that's basically what I wanted to show you. That's what they mean by you taking a portion of a curve and rotating it 360 degrees, also known as 2 pi radians, about an x-axis. By doing that, just like what the video showed you, it would produce a shape, a solid, and it's called the solid of revolution. Why revolution? Well, we know when we go in a complete circle, we say it's one cycle, or you might say one revolution. Hence, it's called the solid of revolution. Do you understand that? Yes? No? Would you like to see it again? Or you get to it? Are you good?
Yes, miss.
Okay, so that was just to show you what that looks like. So what exactly are we trying to do? Well, you see that shape there that I just showed you, and shapes similar to it. What this is going to help me to figure out is the volume of that shape, right? So that's all we're trying to do, find the volume of that solid. How do you do that? Just like the area had a formula, to find the volume of a solid, you need to use a formula as well. And the formula is pi by the integral of f of x squared. So you see whatever the equation of the curve is, you're going to square it in this case. So f of x squared dx. And of course, you need your upper limit and your lower limit, right? Because this is definite integration. Upper limit is b, lower limit is b. Just like the area had units, it was units squared or square units. In this case, the volume is units cubed or cubic unit or whatever the given unit is, right? So they gave you centimeters, centimeters cubed. Yeah. Time to practice. So copy down the first question for me and we'll do it together.